Hi, so this video is for question 7 of paper 2 at Maths SPM 2019. So we're told that, let me just give you a fuller screen right here so you can read the questions clearly. Right, you're given that a metal solid is formed by combining a cone and a cylinder with a common radius. Okay, so it kind of ends up looking like a rocket, if you will. And the total surface area of the solid in a centimeter square is given by A equals to this, blah, blah, blah. Okay, fine. So A1, the solid expands when heated. Okay, it is given that the surface area of the solid changes at the rate of 1.4 pi centimeter square per second. Okay, find the rate of change of its radius. Okay, when its radius is 6 cm. Well, that's a dA dt thing, and you're supposed to find dr dt. So this straightforward differentiation with respect to time. That's easy. Question 2. Find the approximate change in the surface area of the solid in terms of pi when its radius increases from 6 cm to 6.02. Okay, that's just a numerical replacement of delta r into the dA dr formula. Right? So this is just simple first principles of calculus. Okay, so there you go. 6 marks done. If a solid of the same shape is to be formed in such a way, right? In such a way that the total surface area is a minimum, then find that minimum total surface area of the solid in terms of pi. Again, it's a dA dr thing. Find the lowest value of A by equating the dA dr to a minimum. Okay, right. So looks simple enough. So let's give that a go. And oops. Okay, I didn't want to do that. I wanted to snap this to the left, so you have a good view of both the question and the answer. Righty-ho. So, question 7, A1. So we are given that A is equal to 2 pi. Okay, the line's a little bit thick, so I'm just going to reduce that so it's not so hard to read. Oh, that's much better. 18 over r plus r squared over 3. Okay, so let's just differentiate this with respect to time. That gives us dA dt is equals to 2 pi. That's negative 18 over r squared plus 2r over 3, if I'm not mistaken. And looks about right. And dr dt. Okay. Now, we're given that dA dt at that specific instance is 1.4 pi, and find the rate of change when its radius is 6. Okay, so we're given that when r equals 6, dA dt is equal to 1.4 pi. Okay, so therefore, Therefore, 1.4 pi is equals to 2 pi negative 18 over 6 squared plus 2 into 6 divided by 3 dr dt. Okay, so the pi's cancel out. Very nice. Let's just leave the 2 there. Well, fine. 18 over 6 squared is 3 over 6, which is minus half, and that is 4. 4 minus half is 3.5. Okay, dr dt. So very conveniently that cancels out. That gives you dr dt. That is 14 over 10. That gives you 2 over 10, which is 0.2. 0.2 centimeter per second. Done. Okay, that's question A1 done. Question A2. Find the approximate change of surface area of the solid in terms of pi when its radius increases from 6 to 6.02. Okay, so let's just restate that dA dt formula in terms of dA dr instead. So that gives you 2 pi negative 18 over r squared plus 2r over 3. increases from 6 to 6.02. Let's say delta R equals obviously 0.02. Okay, and we have delta A is approximately equal to dA dr at R equals 6 multiplied by delta R. Okay, and that of course is equal to 2 pi negative 18 over 6 square plus 2 into 6, 3, and times 0.02. Find the approximate change in terms of pi, right? So you don't have to even evaluate pi, which is really nice. Okay, and we already knew this was a 7 over 2, right? Yep, that was 7 over 2. So the 2's cancel. We have 0.07 times 2, which is equals to 0.14 pi. Okay, the examiners are not going to like that, so let's just do 0. Write that out clearly. 0.14 pi centimeters square. That is a change. Alright, there's no time factor, there's no time element or whatever. The unit is simply cm square. Done. Right, let's go to question B. If a solid of the same shape is to form blah 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 blah, find the minimum. Okay, fine. So when A is minimum, okay, we have two conditions, right? We have first thing that dA dr must be 0, and secondly d2a dr square must be greater than 0, right? It's got to be positive. Okay, so let's start with the first requirement. We have dA dr equals to 0. That's 2 pi. Okay, so we have 2 pi negative 18 over r square plus 2r over 3 equals to 0. Cut. Sort that over, get the ruler out of the way, put that over, that becomes positive, that's 9, r equals 3. Okay, now let's check for the second one. Whoa. Let's see, d2a dr square. Let's work out what that is. Differentiate that one more time. That becomes positive 36 over r cubed, and that's just 2/3, right? That's 2 pi positive 36 over r cubed plus 2/3, okay, which is always greater than 0, so that's satisfied, right? Therefore A is minimum at r equals 3, okay, and the question is not looking for 3, the question is asking for the minimum A, so we just substitute 3 into the A equation, which is 2 pi 18 over r. What is that? 18 over r is 6. 6 plus 3 is 9. 9 times 2 is 18 pi. And there you go. cm square. Alright, that's question 7 done.